Debugging Demo Part B, a quick introduction of the main concepts presented in this lecture. Debug windows are a collection of windows that provide data from the microcontroller's various registers. Step into and step over are two closely related ways for controlling the execution of a program. They allow the execution of one instruction at a time. Step into allows drilling and stopping into the functions that an instruction calls, while step over will execute but not stop at function instructions. Okay, let's move on. So back to the debug menu. A couple of other windows that I'd like to show you are, let's see, the processor status. So the processor status shows me what's happening inside the processor, the program counter, stack pointer, link register, all these things that are basically tucked into the processor, and there's no other way to look at them other than by using a debugger. These are not values that you can extract through a print statement. And all the registers here, you can also have a look at the registers by bringing up a dedicated register window, this one here. Right, so you can see the registers. Another thing is that you can say to your debugger that I'd like to jump to another line in my code for executing my code. Right now I'm at 13C, which is this location here. So you could jump to another location further down if you want. Next, I'd like to show you what the debugging commands for step into and step over do. So to do that, I will just remove the existing breakpoints. Just delete that, and that, and that. I'm not going to need them. With the breakpoints disabled, I'm just going to create one breakpoint here because I'd like the program to stop here, and then show you what happens with the step into and step over functions. My program is now stopped at the counter line 27. Now if I hit step over, so I'm just going to do F10 on my keyboard, you can see that it's moving on to the next line, and it stops at the next line. Haven't executed that yet. In order to execute the next line, I will do another step over, and then moves back to 27, 28, F10, continuing with the first if statement in line 29, and so on. So in this case, counter was 129, so the remainder with the division to 2 was a 1. So the condition in line 37 was true, so it went into the line 39 inside the if block statement. And from there again with another F10, it will continue and complete the instructions inside the block, and so on. So with F10, which is step over, you can just execute one line after the other without actually branching into any functions that may be necessary to execute for a particular instruction. But if I use step into, so if I use this command here, step into, which is F11, then I'm asking Atmel Studio, the debugger, to get into a function that implements the instruction that my cursor was just over. So what I mean by that is this. I'm going to hit F11 at this location, and you can see that because in line 27 all the instruction was doing is to just update a variable, and that does not depend on any functions at a lower level. I just moved into line 28. But in line 28, I've got a serial.println instruction, which is implemented via a library function somewhere in the library. So if I hit F11 again, so once I hit F11 again, you can see that now from serial.println in my sketch.cpp program, I jumped into print cpp, and in the println cpp function, in particular of that file, and if I look at the Solution Explorer, you'll see that what I'm looking at now is the source code from the core library that comes with the Arduino IDE, and in particular the print.cpp file in that library. And I've also landed, and I'm now waiting and stopped in the first line of the println function. So this is the effect of stepping into. When you step into, the debugger will drill into a function for the instruction that you called, and it will continue drilling until it hits basically the bottom of the stack. If I hit F11 again here, you can see that I've got a function print, which takes in a couple of statements. So by doing F11, then I just jumped into that function as well. I'm just following the trace of all the different functions that implement this single specific function in my sketch. If I want to finally get out of this, because these things are not really written by me, so I don't expect to find any problems here as I'm debugging my own sketch, I just do F10 and go back eventually to my sketch. Alright, there you go. So I'm out of 0 println, and now I'm in line 29 of my own sketch. I can also tell Atmel Studio Debugger where I'd like it to stop next by just using the cursor. So if I'd like the debugger to stop execution, say at this position in line 39, then I can just put my cursor here and then select Run to Cursor from the menu, and it will do what it has to do eventually, and finally stop at the cursor. Did it? Maybe not. Oh, it stopped at the counter before it reached the cursor. So let's continue with F5. Try again. It's because I've got the breakpoint in line 27. Alright, and now the next break was at the cursor in line 31. Another thing you can do with the breakpoints, you've got the breakpoints tab here, and you can enable or disable breakpoints. Right, so now I've got all the breakpoints disabled, and I'll put my cursor, say, in line 39 and run to it. And there you go, it stops in line 39, and you can enable breakpoints at will. You can also restart the debugging session. This is going to bring the sketch on the microcontroller back to its original state, and you can start right at the beginning. Let's pause. You can see that the counter here is back to 8. I did a few cycles inside the loop after I restarted it, and when I stopped it, it was at value 8. At this point, it's worth just recapping what we've done. The debugger in the Atmel Studio is a very powerful feature, and it's worth looking into this IDE just for this. If your sketches start getting bigger than a certain size that you can fit inside an Arduino Uno, the bigger a sketch becomes, the more likelihood of errors that require a debugger to really find out and correct. So at that point is when Atmel Studio with its debugger becomes very useful. If you are familiar with debuggers in pure software applications like in Eclipse, for example, or Visual Studio or other types of full IDEs, then you'll find the features in the Atmel Studio debug menu very familiar. If you're not, just spend a bit of time with these features to get a feel of what they do, especially how they step into, over, and step out, which I didn't really talk about, but you'll understand it once you start using it. Spend a bit of time, and it will save you with a lot of hassles in debugging applications. I find the ability to look inside the processor and see what's happening with these registers very useful. If you are on an operating system other than Microsoft Windows, then you will not be able to use Atmel Studio without a virtual machine, or at least having a partition on your computer running Windows. Personally, I find that Atmel Studio works perfectly well inside a virtual machine. If you don't have Microsoft Windows and you don't want to install Microsoft Windows as a virtual machine on your computer, then another option that you have in order to do debugging with the Arduino Zero or other Atmel debuggers is to use the open source OpenCD with its DBG debugger software. These are options that run on the command line, and they're cross-platform compatible and quite powerful as well. They don't have the graphical user interface that Atmel Studio does, but on their own, they're very good solutions, and once you get the hang of using the command line, they're also very fast and efficient. And I'll show you how to do this in the next section. But before we close this section, there's one more thing I want to show you in the next lecture, and that is an interesting situation that happens with the bootloader on your Arduino Zero, which in fact is erased by Atmel Studio, and unless you reburn it using your Arduino IDE, you're not going to be able to use the classic Arduino IDE. Have a look at the next lecture, and it will make perfect sense then.